The topic from the module 4. There are three types of linked list: singly linked list, circular linked list, and doubly linked list. We already know that singly linked list and circular linked list concept. The next one is the doubly linked list. In a singly linked list, one can move starting from the header node to any node in one direction only, that is from left to right. This is why a singly linked list, also termed as a one-way list. On the other hand, a doubly linked list is a two-way list because one can move in either direction, either from left to right or from right to left. This is accomplished by maintaining two link fields instead of one as in the singly linked list. A single structure is this one. For a doubly linked list concept, this one is known as a single node with three parts. The first one is pointing to the left node, and this one is pointing to the right node, and this one is known as the information field. That is, there are three fields: left link, right link, and this one is info. These are the concept of doubly linked list. Next one is the operations of a doubly linked list. There are insertion, deletion, traversal operations are similar to singly linked list and circular linked list. The first topic is insertion operation. The first one is you have to create a doubly linked list. That is into data. That is the data. Then you have to create one node. This one is the node. Then this one is known as temp. Then using the dynamic memory allocation, then temp of previous is set to, this one is the null, and the temp of next is set to null. Enter value to node, that is the data. Temp of info is this position, that is for example the info is 10, this one is here. Then count plus 1, that is for the counting purpose, that is initialize count is equal to 0. For here you have to create a node, that means count is equal to count plus 1. This is the creation process for insertion. Insert begin, there is a node, the node name is head, then its left link is empty, also its information part is empty. Then its right link is set to null. That is the first process. If head is equal to null, for here head is equal to null, create. Create means you have to create a node. That is a node. Its left link is set to empty and its right link is set to empty. Then we have to read, that is for example 10. Then node name is temp. These are highlighted in the previous slides. That is, just assume temp is equal to 100. Then head is equal to null, create head is equal to temp. That is, this null is changed to temp, that is 100. That is, this one is pointing to the new node. That is the first process. Else case, that is head is not is equal to null. Here head is not is equal to null. Then we have to add one more node. Just assume this one is the new node, its left link is set to null and its right link is set to null. Then data is 20. This one is the new temp. Just assume temp is equal to 200. There is a creation process. These are in the this step. then temp of next is equal to head. That is temp of next is this one. That is temp of next is equal to head means head is 100. This one is 100. That means it is pointing to here. Then head of previous, that is 100. Head is 100, then 100 previous, there's are in this position. This one is changed to new temp, that is 200, that is here. Then head is equal to temp, that is this 100 is changed to temp is 200, that is 200 pointing to here. Then temp next is changed to 100. Then this one is pointing to new node. Then temp, this 100 is changing to the previous node, that is the previous node is 200. That is we have to insert an element to the begin. These are the second step. These are in these steps. Next one is insert an element to the end position. If head is equal to null, creation head is equal to temp. These are in the previous slide. That is insert an element to the begin, first step. Then else case, create. That is, for example, these are the nodes. Just assume 100. Then this one is the head. Then head, that is 100 is the next point, and that is this one is pointing to here. Then its previous node is null and its next node is null. Then data is 10. Okay, these are this step. PTR is equal to head. That is PTR is equal to head means PTR is equal to head means that is 100. Then while PTR of next not is equal to null, that is 100 next is null, that is a null not is equal to null is a false case. Then PTR of next, that is PTR of PTR, that is you have to add one more node here. That is a creation process, create this one, that is the temp, that is just assume this one is 200, then his previous link is null, next link is null, and the data is 20. PTR is head, that is PTR is equal to 100. PTR of next, that is 100 next is null, null not is equal to null is a false case. Then PTR of next, that is 100 next, 100 next is equal to temp. That is PTR of next, that is 100 next is this position. This one is changed to temp, that is 200. And temp of previous, that is temp is 200, then is 200 previous is this position, that is this one is changed to this temp of previous, that is 200 previous is equal to PTR. PTR is 100, that is here. This one is pointing to this particular node and this one is pointing to this particular node. That is the process. That is 100. That is the first node pointing to the second node is 200, and 200 is the second node, that is the previous pointing to the first node. That is the insert and end. That is first node is 100 and second node is 200. Insert an element to the last position. The next one is insert an element to the a certain position. Just assume I is equal to 2. That is the initialization process. Read position. Just assume we have to read the position. Position is equal to 2. That is we have to insert a particular node to the second position. PTR is equal to head. That is the starting node. Position less than 1. That is here position is equal to 2. Okay. Then position greater than or is equal to count plus 1. That is if there are only one node. That is one node. For example, we already know that the counting process in the creation process. Then for example, there is in our linked list only one node. Then count is equal to 1. 1 plus 1. That is 2. That is the position is greater than or is equal to 2. That is print position out of range to insert return process. This insertion is not in use in this particular problem. If head is equal to null and the position not is equal to 1, that means it's an empty list. There is empty list cannot insert other than a first position. That is in the this steps. If head is equal to null and the position is equal to 1, that is similar to insert an element to the begin. There is a first position. That is head is equal to null. This is an empty linked list, and position is equal to 1 means that is we have to insert an element to the first position. That is similar. There is a creation process. Head is equal to temp and retain this one. These are in these steps. This one is the one of the linked list. There is a head starting from the 100. Then 100 is pointing to 200. That is the 200. There are two nodes. Then 100 next is pointing to 200, and 200 previous is pointing to 100. There are two nodes in the given doubly linked list. Then position is equal to 2. There is I is equal to 2 less than 2. That is a condition is false. Then create process, that is you have to add one more node. That is, just assume this one is 300. Then this one is temp. Then previous link is pointing to null and next link is pointing to null. Then the information part is 30. Temp of previous, that is previous is this one, is equal to PTR. PTR is starting from header node, that is 100. This PTR is equal to header, that is equal to 100. Then temp of previous, that is 300 previous, this one the position, is equal to PTR, that is 100. And temp of next, these are the positions, and is equal to PTR of next. PTR is equal to 100. 100 next is 200. That is, this one is changing to 200. And PTR of next, that is 100 is the PTR. PTR of next is 200. 200 previous, that is, these are the position. This one is the position. That position is changed to temp. Temp is equal to 300. That is, this one is changing to 300. And PTR of next, that is 100 is the PTR. PTR of next is 200. 200. This position is changing to 300. Okay, these are the process. After the process, this one is the result. That is 100 pointing to 300 and 300 pointing to 200. Then 200 previous is 300 and 300 previous is 100. Then header is 100. That is, we have to insert an element to the second position. This one is the second position. Okay, these are the process. These are the insertion process. That is the first one, creation. Second one is insert an element to the begin position, and the second one is the insert an element to last position. This one is the insert a position.